Guys, how's it going? In this video I'm going to run you through how to find the equation of a tangent to a circle. So if you're not sure on these and you want more examples, I'm putting a link to my equations of tangents playlist down below this video in the description, where there's a separate video for each of the little skills that we're using, and then a big finale video with more examples of finding tangents. So how do we do these then? Well, first of all, I explain the setup to you. So here we have a circle, centre the point O, which has coordinates 0, 0. We've then got a tangent, which is our blue line here, which hits the circle at this point P with coordinates 3, 4. So our mission is to find the equation of the blue line. How do we do that? Good question. Well, the first thing that we need to do is find the equation of the radius. So the radius is the line that comes out from the centre of the circle and hits the circumference of the circle. In particular, we are interested in the radius between the centre of the circle and the point P. Why? Well, it's because a radius and a tangent meet at right angles, so they are perpendicular. So I'm going to put a little right angle here. So how do we find the gradient of the radius? Well, so I'm going to call this with a little r. Gradient I teach as the difference in y over the difference in x. So here our coordinates at point O are 0, 0. So our gradient of our radius is 4 minus 0 over 3 minus 0, which is just 4 thirds. Why is that useful? Well, if two lines are perpendicular, then their gradients multiply together to give us minus 1. So we know then the gradient of the radius times the gradient of the tangent is equal to minus 1. Now we know the gradient of the radius is 4 thirds. So 4 thirds times the gradient of the tangent is equal to minus 1. So if we divide by 4 thirds, we can get the gradient of the tangent is minus 1 divided by 4 thirds. Now if you divide by a fraction, you flip that fraction over and multiply by it. So this is minus 1 times 3 quarters, which gives us minus 3 quarters. So getting the gradient of the tangent is our first really big stepping stone towards getting the equation of Mr. Tangent. So I'll clear this up and we'll do the next step. Okay, so now that we know the gradient of the tangent, it's now time to whip out y equals mx plus c, the general equation of a straight line. So for our tangent, we now know that m is minus 3 quarters. So we get y is equal to minus 3 quarters x plus c. So we now just need to work out the value of c. To do that, we substitute in the set of coordinates that we know lie on the tangent. So 3, 4. So that is telling us when x is equal to 3, y is equal to 4. So we get 4 is equal to minus 3 quarters times 3 plus C. Now when you multiply a fraction by a whole number, it just multiplies the top. So we get 4 is minus 9 quarters plus C. And now we need to get what C is. So there's quite a few ways we could do this. We could turn minus 9 quarters into a mixed number or a decimal. The way that I'm going to do it, I'm going to turn 4 into an improper fraction in terms of quarters. So every one whole is 4 quarters. 4 wholes then is 4 times 4 quarters, which is 16 quarters. So we get 16 quarters equals minus 9 quarters plus C. Then add the 9 quarters. Finally we get 25 quarters is equal to C. So we now know the equation of our tangent is y is equal to minus 3 quarters x plus 25 quarters. Jobs again. Okay guys, so if that's been tricky, it's quite likely it's going to come up. I would recommend checking out the videos in the playlist again, which is down below this video in the description. Okay guys, take care.